Hi, welcome to ANZAM Explains. I am your host Zian ANZAM. In this episode, we are going to talk about 3D bioprinting. Bioprinting is an additive manufacturing process where biomaterials such as cells and growth factors are combined to create tissue-like structures that imitate natural tissues. This technology uses a material known as bioink to create these structures in a layer-by-layer manner. Bioprinting technique is widely applicable to the fields of medicine and bioengineering. In essence, bioprinting works in a similar way to conventional 3D printing. A digital model becomes a physical 3D object layer by layer. In this instance, however, a living cell suspension is utilized instead of a thermoplastic or a resin. For this reason, in order to optimize cell viability and achieve a printing resolution adequate for a correct cell matrix structure, it's necessary to maintain sterile printing conditions. This ensures accuracy in complex tissues, requisite cell-to-cell distances, and correct output. Moreover, to create conditions fostering the fastest and the most efficient cell growth, researchers plan the cell around a 3D scaffolds made of biodegradable polymers or collagen, so they can grow into a fully functional tissue. The complete process of bioprinting principally involves preparation, printing, maturation, and application. This can be summarized in the three key steps: pre-bioprinting, bioprinting, and post-bioprinting. Pre-bioprinting involves creating the digital model that the printer will produce. The technologies used are computer tomography or CT and magnetic resonance imaging or MRI scans. Bioprinting is the actual printing process where bioink is placed in a printer cartridge and deposition takes place based on the digital model. Post-bioprinting is the mechanical and chemical stimulation of printed parts so as to create stable structures for the biological material. A typical bioprinting process standard series of steps, and these are 3D imaging. To get the exact dimensions of a tissue, a standard CT or MRI scan is used. For 3D modeling, a blueprint is generated using AutoCAD software. In the case of bioink preparation, bioink is a combination of living cells and a compatible base like collagen, gelatin, silk, alginate, or nanocellulose. In printing, the 3D printing process involves depositing the bioink layer by layer, where each layer has a thickness of 0.5 mm or millimeter or less than that. The mixture comes out of the nozzle as a highly viscous fluid. In the step of solidification, as deposition takes place, the layer starts as a viscous liquid and solidifies to hold its shape. The process of blending and solidification is known as cross-linking and may be aided by UV light or specific chemicals. As you all know, 3D bioprinting is the future, so many companies are emerging behind this technology. Some among them are CellLink, Aspect Biosystems, and Organo. In this episode, let's talk about one among them. The most well-known tissue engineering company is a San Diego-based company called Organo. It has been actively developing a line of human tissues for the use in medical research and drug discovery. These include both normal tissues and specially designed disease models. They are also working on the development of specific tissues for use in clinical patient care. In 2014, they announced the successful printing of the liver tissue that even functioned as a real liver for weeks. A year later, fully functional human kidney with tubular tissues were generated. with the company's 3D bioprinter. Organovo also teamed up with L'Oreal to advance the development of synthetic skin. You have to know bioprinting is actually difficult and time consuming. Mass production is highly unlikely in the next decades, and we are even further away from printing complex organs. And even if the technology becomes more available, tissue engineering will be more feasible than printing out entire organs. Synthetic skin, a bionic ear, bladder, or cornea might be the first tissues to be either bioprinted or grown in the lab on demand, since they are the tissues containing a small number of cell types. After that, more complicated ones might be engineered. The idea of lab-grown organs might mean the end of testing drugs on animals or humans, the solution for organ shortages, and an ending of the desperate state of organ donations worldwide. In the future, you would most definitely not need a fully grown humans as holders of backup organs or surrogate mothers. Bioprinting specific tissues or organ parts might be enough for us. Thank you for listening. If you like this episode, or if you like listening to ANZAM Explains, you can support me by buying me a coffee from the link in my description. Thank you.